Hello friends, we are here to present to you a viable way of making lightsabers, and here we go. When it comes to sci-fi weapons, few come as iconic and awesome as the granddaddy of them, the lightsaber. Wielded by Jedi, Sith and man-children with an overabundance of fun, the light sword is the kind of dream tech that manages to take the sounding cool and looking cool boxes all at once. No, it's not light or the electromagnetic wave that makes lightsaber possible. First, like light, lasers don't bend. They just go straight until they connect with something. So you would need a way to make the beam stop at some desired length or figure out a way to wield an infinitely long beam of death. Secondly, to cut anything, we need to bombard it with some mass. But light, having no mass as such, would not be able to cut anything.
Right off the bat, you would assume the blade of a lightsaber to be one giant laser, one with enough power to cut through flesh like butter and melt steel. The thing is, a lightsaber is typically around 4 to 4.5 meters in length, but it's scientifically impossible to control the length of a laser. So, even if we did invent one powerful enough to generate such energy, you would just end up swatting X Wings out of the sky every time you turn it on.
Now we will take a look at the fourth state of matter, which is also known as plasma. Plasma is made by heating a gas until its electrons have sufficient energy to escape the hold of the positively charged nuclei. As molecular bonds break and atoms lose electrons, ions are formed. Now we will take a look at the properties of the plasma. Plasma consists of charged particles, hence it reacts to electromagnetic fields and conducts electricity. In contrast, most gases are electrical insulators. And we also know plasma has neither a defined shape nor a definite volume. And when plasma is exposed to a magnetic field, it may assume structures including layers, filaments, and beams. A good example of some of these structures can be observed in the plasma ball. Plasma is also used in television, neon signs, and fluorescence light. And the most common example we observe of plasma include the sun, lightning, and the fire.
Now we'll explain to you a feasible solution of making a lightsaber. Firstly, we'll have to make a magnetic confinement area. This means creating a retractable blade around a plasma vortex. Secondly, we'll have to make a magnetic bottle in which we can discharge noble gas in it. Next, we ionize the gas to get the characteristic color. Now this shows the lightsaber in the compressed mode. As from the marking, you can see that there are two conducting materials, one at the tip of the blade and the other at the base. Further, we start an electric discharge. This occurs between the conducting elements at the two ends of the lightsabers. This can be viewed as the lightning between them. Having seen how we can create a single arc between them, so when they are spherically made symmetric, it forms a sort of a sheath, which is a blanket. This is what defines the magnetic confinement area that would further hold the plasma. Since this is all retractable, the tip could be extended this way. Now we have formed the saber. Our next task is to make and confine the plasma in it. This here typically shows the electrical cross section of the lightsaber. You can see the magnetic lines and how all of these is possible. This shows the same saber when extended. This is like the skeletal frame of the saber. Now the noble gas is injected into the space confined in the confinement area. This can be seen by the arrows that have been drawn. It is here that the gas is released. And now happens the most crucial and the important thing. A huge electric discharge is enforced in the confinement area. This forces the electrons of the noble gas atoms to gain enough energy to split or leave the atom. This leads to free electrons and cations. This is what plasma actually is. Hence we have made plasma. Now how do we ensure that it does not leak? This is ensured because the sheath of electric field is very good at decaying plasma radiations. So this way the plasma remains confined and the saber maintains its shape. Now let's have a look at the noble gases that various Star Wars characters would have used to actually make their lightsabers a reality. So Vader would have to use neon gas because in the emission spectrum of neon gas it emits red light. Similarly, Obi-Wan Kenobi would have to use xenon gas because that emits blue light. Luke Skywalker would have to use mercury because that emits green light. Mace Windu would have to use argon because in its emission spectrum argon is released. So thank you guys to listening to us.